Guys, we're back in Rhode Island today, and we got a lot to update on. Brian, last time we were here, I actually walked through the girt install, but you guys have some of the plywood up. We were doing the roof. We talked about why we were using the zip because we're struggling with Tesla. So if anyone has contact at the Tesla Energy company from a marketing perspective, would love to reach out. The roof's pretty straightforward, but the sidewall is not as straightforward. We have the 2 layers of the insulation, and there's a lot of detailing that I kind of walked through in the last episode of like how this window terminates. But walk me through what we got going on, how, you know, from attaching to the girt, what are these clips that we're using in the seams of the plywood? Just give me an overall kind of rundown of what's going on the sidewall.
Yeah, I mean, it may be working backwards. You know, you see the H clips on the plywood, and it's to just kind of keep things straight and aligned.
So these are the H clips here.
Yep. You know, it's 1/2-inch plywood. We're not using 3/4. It's, you know, we've got 2 layers of 1/2-inch. One on the inner, obviously, if you
behind that first layer of
the inner, with the membrane on it, and then we've got the 2 layers of 3-inch insulation followed by that 1/2-inch.
So Chris was saying that the H clips, well, a couple people had mentioned, like, you know, why isn't this continuous? You're spacing them out every 24 inches on center, or screwing every 24 inches on center. But there was some concern with, especially CDX, you know, if they were going to bow in between our supports, either vertically or horizontally, and that's really where those came from, right?
Right. I mean, that was a suggestion from our framer. He's used those H clips before. You see them more commonly used, you know, when you're sheathing a roof, right? And it's just to kind of keep it stable, because, you know, 1/2-inch plywood likes to, you know,
do its thing.
I think it's like a Pringle, you know. So he suggested that just to keep things tight and aligned. We went to just 4-inch pieces. That was, you know, the owner's, you know, thought architect. She wants to make sure that the, you know, keep the price down. Much, and
if you're using less material.
Yeah.
Because otherwise, like this section here would have been filled, and, you know, while we would have had more screwing, we actually didn't need it. We talked to the engineer. Yeah. So what did we determine as far as what screws we were using, and how did we determine that?
A lot of that was to do with making sure that enough of the threads got into that, you know, the front of that girt. You know, there's screws that actually have sort of a smooth shaft on them, and we wanted to make sure that we had good grip. We also had Ben at H&O make some suggestions, especially as far as how those attach to the, you know, to the framing.
Right.
We used the Simpson SDS, the structural screws.
From the girt into the framing on the main part of the house.
Yeah, so those are at least 2.5 inches on the outside, 3 inches on the roof.
So to ask the question that's come up on YouTube, you know, why are we using the girt system rather than doing 2 layers and screwing through the plywood into that stud?
Right. You know, we've definitely, you know, struggled with this idea of a very thick insulation, 6 inches, where, you know, you got 2 pieces of plywood converging, and you have to, if you were going to use a long screw, you have to hit the stud. If you don't hit the stud, you only have a couple of threads holding this entire thing on, and we're kind of in a hurricane zone, and, you know, you get a force, it can just tear the thing right off the house. You know?
Right. So you're talking about kind of in this location here, where, you know, if this was a 6-inch screw, you have to go back and make sure you
maybe
get
a slight angle, right?
Right, and make sure that you hit dead on, and that and like you just said, there was an actual structural concern as far as uplift and the wind load. So this actually resolved it based on the engineering that H&O had done. Is that right?
Yeah, and there's also kind of it's an interesting thing that came up in a conversation last week, that I guess there's more conduction that occurs with a metal screw than, you know, maybe people would originally think. Yeah, Julie and I were talking about it. She mentioned that, you know, they do conduct, you know,
thermally. Yeah,
thermally.
Less than what this girt is, and this is a fiberglass.
Yeah, the trick obviously is to make sure we get that insulation tight, and Chris and his crew really did labor over, you know, you could see they kind of notched the insulation around it to get a nice tight seal. There's not a lot of gaps here, and I'm actually really happy with the install, the execution of that.
Yeah, and you know, frankly, you guys had said, well, now you can't overlap or you know, offset, you know, the layers, which is true. But at the end of the day, I mean, even if this is a seam over a seam, I mean, we have 6 inches of insulation. I think that the minor areas that might be, you know, if wind truly gets through something like that, which it really is not going to once we have our air barrier that's on top of, but it's not even our air barrier, but it's going to act as an air barrier as well, barrier over the plywood. So the reality of wind driving between those seams is so minor. Flipping over here, so we have a lot of plywood installed, but we have a lot of sections left over, but I see a lot of mechanical. What is this here?
This is one of our ERV penetrations.
Okay.
So that's
so
an energy recovery ventilator.
We have our intake as well as our exhaust. And they have to be separated, right?
Yeah, they have to be a distance of, I believe it's 10 feet.
10 feet, right.
Yeah.
So that way you're not intaking air that you're exhausting. This is getting true fresh air from the outside. Now I see that there is a damper in here now, but this is going to likely be removed,
It's
right?
going to be modified, yeah. We have to put a bug screen on that, and you know, even on the exhaust, they were thinking that there may not be enough air movement this might actually work against it. So, you know, the ERV has its own, you know, flappers inside of it where it can, you know,
kind
modulate.
of prevent that backflow of air.
Yep, exactly.
Now, what about height-wise? I see shingle course number 7, bottom. What does that mean?
The bottom of the 7th course of shingles, we have a line here. We've got 2 lines, you know, just to show this 5-inch course of shingles. Obviously, if it's off a little bit, as long as it's level, we could, you know, divide the courses as we start, you know, to hit that dead on as we go up. Make a story pole, make it so that everything goes up the same.
And that's, you know, pretty typical from a siding installer. They'll go around and find out all our heights and modify rows so you aren't notching around that. And that's really what you guys are trying to prevent here, is making sure that your shingle course worked exactly where it was.
Yeah.
So where's the other one of this?
It's right over here. It's
on the front here.
Actually, they did just install it, which is great.
Look at that. They knew we were about to film.
Yeah, we want to make sure this is level and it's level this way, and that, you know, now our insulation can come in. Plywood goes right behind that flange. We tape it up and around. And
then that shingle comes right on top of it.
Exactly.
So we'll actually do some air sealing detail, probably tape this right onto the ductwork, and then they'll take that from there and make sure that ductwork is airtight for the ERV itself.
Yep.
And then, so this is, you know, one of our last penetrations. I saw a bunch of wire penetrations. So the electricians are on site, which is huge because that's our third and final trade for MEPs before we get into our rough inspections. But let's look at the detailing that you have for penetrating into the envelope, because that's critical for the passive home. And we have a lot of wiring coming from the garage into the home. So to start, Brian, you get all of your electrical equipment in the garage, is that right?
Yes, there's you know, there's going to be a Tesla Powerwall.
So we have our power coming in. Doug asked me if we're going to be in the garage beforehand, and I said no, and he didn't want his bag in the shop, but his bag's in the shop. You guys deal with it. The power comes in over here, and then we have Tesla Powerwall, which some of the equipment's going to live on this side, a bunch of the equipment's going to live on this side, but this is outside the envelope. So anything that penetrates through the garage is fine. You can lump the wires together, but it's when we get to there that's really critical. So how did you handle that?
We talked to the electricians about this, and they have had a lot of experience with it, and you know, very accommodating as far as making sure that the wires up to the top of that door there came out separately.
So that each one of those wires comes out of a separate hole.
Exactly, and they're spaced apart so that the tape can be, you know, sealed around each one individually.
So you're taking one piece of tape underneath those wires, basically folding it down and then putting another piece of tape on top, and then sealing in between, and that creates your airtight seal.
Yeah, it does.
So one thing we talked about, we were up at Siga's headquarters up in Salem, New Hampshire, and we were talking about, well, when you penetrate, you can use like a sealant or a caulking. But the nice part about that is when a wire moves back and forth, there's a lot connected to that.
Yeah.
And you don't have that. You don't risk that chance of pulling that sealant through the hole. You know, when it's only
when yanks on it. Yeah.
Exactly.
Yep.
We're also talking about adding some conduit for future use as well, right?
Right.
And we'll do the same thing there. We'll basically bridge from the main home to the garage, and then cap it, you know, until it's necessary. And then if we have to go back and reuse it, I think Ben was saying that you basically fill that tube with
some spray foam or something.
Foam or a sealant or something like that. Yeah.
Acoustic sealant or something.
So why don't we go inside? And on the right here, this is actually where our future panel is going to be. Is that right?
Yes.
And we're going to be working with the guys at Spam Panel. They're going to be providing us a 200 amp panel. What is the benefit of using a panel like that?
I mean, it's an intelligent panel, and there's some situations like if you had a power outage, and you're just running off the Tesla batteries, what is getting prioritized.
So you can actually prioritize within that. I think there's like a computer brain or something like that you can kind of modulate based on what your needs are.
Yeah, and it messages, it sends messages to the client, that the power's down, or this is your utilization, anything like that.
Right.
So that helps them kind of figure out what circuits are going to get power when the power goes out. There may be more to it that I haven't learned yet, but
we're about to learn
yep,
it. So
totally.
that panel should be, I believe, showing up this week, but everything is being ran to this location. But as we walk into the main living space, Brian, we didn't even talk about the fact that you guys got the skylights in. So before we get into the electrical, let's just talk about the skylights. We had struggled for weeks, really, to figure out how those skylights were going to be installed. So much so that we almost had to return flashing kits and things like that.
Yeah.
What was the main driver of delaying these skylights from being installed?
I think lesson learned. We should have reached out and found anyone with experience installing the Tesla roof, even if they weren't going to be our installer.
Sure.
To find someone, and actually you helped us find somebody to talk to, who was a quality assurance guy, and basically he told us, whether or not we could do it a certain way, whether or not we could just put our skylights like a typical install. They have a 4-inch, built-in, curb on them, instead of building them up superficially onto like a 6-inch curb. He told us what we could do and what we couldn't do, and it kind of got us out of our heads. And, so we stopped cycling on, can we do it this way? Can we do it that way? Jumping back and forth between approaches.
Right.
Because we're just speculating, and we didn't really, know all the facts.
And it seemed as though like almost Tesla was just giving us information to basically CYA, where it's like, hey, do this and we know we'll be covered, where the reality is like what we had worked out great. So you guys got this is 3 of 4 skylights, but you got these 3 skylights installed. And for the question about the plywood really just gives us a really flat surface, because there's a ton of natural light that's going to be coming through these throughout the entire year. And this plywood sets that surface up so they can come in and wallboard, plaster that, and make sure that there's a less of a chance that we're going to have humping in that plaster.
Yeah.
And then everything dies right into that frame really tight.
Yes.
Electrical. So you went around and marked everything. You've been working with the team at Social Electric. Floor 1, we got recessed lights everywhere. These are, I believe I'm correct, and these are actually going to all be plastered in, right?
Yes. And somewhere around here they have the ring that pops on them after the blue board goes on.
Yeah, and I remember in one of
through those rings.
In one of the early meetings how important these were to install really flat and straight. And,
yeah.
So you and Julia
exactly.
actually worked on like making sure framing layout would fit everything. Is that right?
Yeah, for the most part. I mean, there's some cases where we had to, reframe some things, like under the stairs over there. We had to cut in, and
sure.
There's a couple of spots like that where we had to kind of move things.
Right. But it was critical. It was really critical for just the install of that can to be perfectly flat in preparation for that board.
Yes.
So I keep seeing all these I'm going to call them curly cues or loops.
Yeah.
What's going on with this here?
I thought this was really neat. I was talking to the foreman about it, and basically when they're putting, the blue board or the drywall on, they use a rotozip tool. You punch it in. They go to the edge of the box, and then they zip around like this to, and they come around the outside and then they zip around. There's a risk that when they punch in that first time, they could actually go through one of these Romex cables. I think I've seen it happen on one of our prior jobs. What this allows them to then do is then pull the wire out and get some more slack if they need it. The other thing is that if they need to move this box up or down or over, they do have the slack they need to do that. I just thought this was really, really nice, the way they thought ahead on this.
Yeah, it
and
makes a lot of sense.
They do it on all their wiring.
It makes sense. So you can see it in every single outlet box over here, and I think even on the floor outlets as well. Brian, I actually had seen, yeah, right here, we have yellow tape. So what's going on with the yellow tape?
Yeah, so I just I went around, looked at the plans, and tried to find the best layout I could based on what I was seeing on the plans. I put those little pieces of tape. I had like a piece of wood marked off as bottom of the box, and there's a strike in the bottom of the
I
stud.
think I saw that, or it was leaning right here a moment ago.
Yeah, the guys actually, it was funny when they showed up. They found it and they started using it too. Like there was bottom box, bottom of switch. And so then basically after those were all laid out, I went through through them with Julia, the architect, and just to confirm that they were where they needed to be.
Make sure everything was in the right spot.
And you can move them pretty easily, if we needed to.
Yeah, and that way it's standardized. Everyone knows what's going on. And they're actually in the basement now getting that roughed out. But so next step for them, they're going to get this place completed, and we're going to be on to our rough inspections. But before that, we got windows and doors to install.
Yeah.
So what are we working on off-site that's prepping us for these window and door installs?
So we have a powder coater. He's out in he's west of Worcester right now, and he's basically putting a finish on all of our custom bent aluminum.
So Mark Jordan fabricated window pans for all of our windows as well as our doors. He's also doing all the custom flashing on the project. But Julia had spec'd a powder coat to match those windows. Those are being powder coated, and they're due into us either today or tomorrow, I believe. And then we'll get, once those are installed, we'll start seeing some glass go in here.
Yeah.
Guys, stay tuned for that next episode when you start seeing all the windows and doors come into this place and get this place dried in.